So this problem 10.42. So this says, so how can you make methane sulfonate ester of cyclohexanol? So you have to prepare this compound. So you have to prepare cyclohexyl methane sulfonate. So this compound, if you want to name this one, so this is cyclohexyl methane sulfonate. So how will you prepare this compound? Using cyclohexanol and appropriate reagent. So you have been given this compound, cyclohexanol, and you can take whatever you want, acid chloride, and you can take acid chloride. How can you prepare this compound? Using cyclohexanol plus acid chloride. Now you see, if you think, it looks like O minus has attacked on something containing sulfur, and sulfur contains a good leaving group. So now you can think something. This is something of twice-late formation. You see, in twice-late formation, what we have TSCl. Cl is a good leaving group, and in that case you have O minus. Same thing you can use here. So this means if I react this compound OH with Cl, are getting, and here you have SO, CH3. Now let us take some base. So in this case pyridine I can take use as a base, or you can take any base. Even you can take sodium, because sodium can release H2, and then you will have O minus. O minus can attack here. So what is finally I am doing? I am taking this H plus, and this lone pair is basically attacking on sulfur. That is the case that is happening. So if I react with pyridine, now this pyridine will act as a base, basically acting as a base. Now this pyridine will take H plus from alcohol. You will have O minus, which will attack, open up, returns back, Cl goes. So you will have finally this compound. There is no point of writing the mechanism. You can understand. O, SO, here you have SO, and here you have CH3. So this is the product you will get. You're getting. Now you copy this one first, and then we'll discuss the next reaction. I think all of you have copied this one. Have you copied or not? If you have copied, then we can go for the next reaction. Now this 10.43. So this says, so how can you convert S2-hexanol to, so you have S2-hexanol, S2-hexanol. So how can you convert S2-hexanol to, first is S2-chloro, hexane. So you have to convert into X2-chlorohexane. So this means, let me write here. So you have, let us say hexanol is this. You will have 6 carbon and S2-hexanol. So at position number 2 you have all group. So you have CH3, 1, 2, 3, 4, 5, 6. At position number 2 you have OH group. Are you getting or not? And then this is S in configuration, and you have to prepare 1, 2, 3, 4, 5, 6. At position number 2 you have to attach a Cl group, and once again this also remains S. So this means, you see, and OH and Cl, in this case if you see the priority order, OH and Cl has same priority order, because if you decide the priority order, here you have hydrogen, here also you have hydrogen, carbon, carbon. Now oxygen has higher priority than carbon, chlorine also has a higher priority, so this will come the first priority. this will also come as a first priority. So OH is first priority, Cl is also first priority. So priority order remains same. This means S has remained same. This means this has gone with retention of configuration. If something has priority order also remains same and nomenclature remains same, in this means this has gone with retention of configuration. So you have to do retention. This means S remains S. In this case, priority order is also same, and that's why S to S is retention. So what kind of reaction you will do so that you go with retention of configuration? Now there is a reagent basically that goes with retention of configuration. So let us remember this reagent. So if I have C345 OH, now if I react, I want Cl here. If I react with SOCl2, are you getting? In the base pyridine, in the case of no pyridine, if I use pyridine, I will have inversion of configuration. So let us say SOCl2 without any base, in that case I will have retention of configuration. So S will give you S product 1, 2, 3, 4, 5, 6. Here you have Cl. Are you getting? Now the B part of question says you convert. You're getting or not? So let us say B part. So what this part says, so let me write part B. This you have to convert R to bromohexane. So this is chloro. Now you have to convert into bromo. So I have to convert R to bromohexane. Only thing you have to add Br in place of Cl, and now you have to have inversion of configuration because this bromo group will also have same priority order. Cl as well as bromo both have same priority order. So you can think OH has converted into Br, but the R has S becomes R, so this goes with inversion. So this time this reaction is inversion. So I need some reagent that goes with inversion of configuration, and that is easy. If you take this one and use pyridine, in case of pyridine, so either you can make first OTS. So what you do is 1, 2. So let me use this pen. So you have 1, 2, 3, 4, 5, 6. Here you have OH. Now let us use with TSCl. So you will have 1, 2, 3, 4, 5, 6. You will have OTS. Now this is a good leaving group. Now treat with Br minus. Are you getting or not? So you treat with NaBr or KBr. Now this is a basically inversion of configuration. This is a SN2 kind of reaction. So you will get the desired product. So you will have initially you have S, but now up to here you will have S. No inversion. TSCl goes simply with retention. Now you will have R. Now in place of OTS you have to have Br added. Are you getting or not? I can show you the same reaction. So you have 1, 2, 3, 4, 5, 6. You have OH. And then you will 1, 2, 3, 4, 5, 6. You will have OTS. So this is S. This will remain S. But now we will have 1, 2, 3, 4, 5, 6. Here you have Br. But now this will go with inversion of configuration. So this will become R. So this is S, this is S. So this goes. So you see how we can proceed this reaction. So if you want to convert alcohol into chloride group or bromide group, you want to have retention, you use reagent SOCl2. If you want to inversion, in that case you first make TSCl and then use some Br minus, you will get the desired product. Are you getting or not? So I think you have copied this one. If you have copied this one, then we can go for the next problem. So let us go for the next problem.